Hi, my name is Ellie Hecker, and this is my Lab 2 on lines of charge. The purpose of this lab was to build off of Lab 1 and further investigate electric charges using strips of tape. We looked at the interactions between objects of different charges and calculated the excess charge using an advanced computational model. We treated the strips of tape as a line charge rather than a point charge like we did in Lab 1. I found that the magnitude of charge on a strip of tape to be 2.3289 e to the negative 8 coulombs, which was more precise than the magnitude that was calculated in Lab 1. Some of the main physics concepts we used in order to conduct this lab experiment were Coulomb's law, the conservation of charge, which states that charges cannot be created or destroyed, Newton's laws of motion, and applications of point charges and distributed charges. Similar to Lab 1, we observed the interactions between the U-tape and other objects in order to determine the charge of the U-tape. After the transfer of electrons between a U-tape and a base tape, we found that the two U-tapes repelled each other. A U-tape was attracted to a neutral book due to an induced dipole, and the U-tape and a negatively charged pin repelled each other. These observations led to the conclusion that the U-tape was negatively charged, meaning it had an excess of electrons. I assumed that each U-tape was treated as a line of charges rather than a single point charge like I had assumed in Lab 1. It was also assumed that each U-tape had the same net charge distributed evenly along the entire length of the tape. To find out the amount of excess charge on the negatively charged U-tape, two pieces of U-tape were floated next to each other as shown in the diagram on the right. When the top tape was a certain distance from the bottom tape, it stopped moving as it reached equilibrium. At each point along the line of charges, the electric force from top A points up with equal magnitude in opposite direction as the force of gravity. When summed up, this gives us a net force of 0 in the y direction. I measured the U-tape to be 0.202 meters, the mass of the tape to be 0.00202 kilograms, the distance between the two tapes when tape B began to float as 0.01 meters. We are using the assumption that the charge of an electron is 1.6 e to the negative 9 coulombs. Using F equals mg, the gravitational force was found to be 0.00198 newtons, which is the same magnitude as the electric force on the floating tape. For the purpose of time, I'll just state the results of the rest of my calculations, but I've included the step-by-step process to reach these results. The charge of the tape when considered a point charge was found to be 4.69 e to the negative 9 coulombs. The number of excess electrons was 2.93 times 10 to the 10th electrons. The number of atoms on the tape was 4 times 10 to the 17th, and the ratio of atoms to the electrons was 7.325 times 10 to the 10 to the negative 8th. My computational model is shown on the right, as well as the magnitudes calculated for the electric and gravitational forces. The red spheres represent the line of charges for tape B, the blue spheres show the line of charges for tape A, the yellow arrow shows the negative gravitational force, while the white arrow is the equal and opposite electric force, and the green arrows show the electric field. The determined magnitude for the charged U-tape was 2.33 times 10 to the negative 8th coulombs. In the first part of my code, the constants are defined and a function is written to calculate the electric field when analyzing each sphere as a separate point charge to make up the line of charges. I came back to line 25 later and varied the value of charge Q until the magnitudes of the electric and gravitational forces were equal. Here, I first edited the positions for the top and bottom tape by adding the separation distance between the two tapes into the code for the top tape. In lines 98 and 107, I edited the scale factors for the electric field and the electric force arrows. The two for loops here iterate through each point charge in the top and bottom tapes. In line 122, I outlined the code for the electric force, and in line 126, I outlined the code for the electric field. Finally, I edited the code for the creation of the arrows representing the force vectors for the gravitational electric forces, which you can see in lines 138 and 142. I calculated the force of gravity by doing the mass times the gravity constant multiplied by a negative direction. To conclude, this lab helped me to better understand line charges and how to use them to estimate electric charges in a more accurate way than we had in Lab 1. When we used the point charge model, I calculated a Q value of 4.69 times 10 to the negative 9th coulombs, while the distributed charge model gave me a Q value of 2.33 times 10 to the negative 8 coulombs. As this shows a pretty reasonable difference in calculations, our results would not be as precise if we had not modeled the tapes as point charges in this lab. These estimates differ because a point charge is not a sufficient way to model the charge on a much larger surface made up of many distributed charges. The line charge model is more accurate than the point charge calculation because the tape is broken up into smaller pieces, and the more smaller pieces we break the tape into, the more precise our approximations will become. Thank you.